So now let's go to number 3. So everything's on one line. So here's the equation, here's the when information, and here's a rate that's given to me, and I want to find the dy over dt. So if I think about taking the derivative with respect to t, both sides, derivative with respect to t, so taking the derivative of x squared gives me 2x times the derivative of the inside, which is dx over dt. To take the derivative of here, I get 2y. Derivative of the inside gives me dy over dt. And then don't forget the derivative of a number is 0. Okay, so now I'm going to look to see what I've got. So let me erase these things. Okay, so let's look back. So they're telling me x is 3. I can put 3 in there. So I have 2 times 3, right? And I think they tell me dx dt is 8. So I put that there. And then let's look at the next one. So I've got plus 2 times, I don't know why right away, so I'm going to stop and think about that. Oh yeah, and dy over dt is what I'm trying to solve for. So that's okay that that's there. So my goal is to find y. So find y. So what I want to do for that is I want to plug in my when information into my original equation. So use x equals 3 into here. And if I put 3 in here, I get 9. I subtract. So I'm going to say, I know y squared is equal to plus or minus 4. We're going to be going to positive because this is going to be in word problems. Oh, joy! And we'll be making them distances. So this will give me 48 plus 2 times 4, right? dy over dt is 0. So I'll get dy over dt is a negative 48 divided by an 8, or a negative 6. All right, let's look at this next one. So here's the equation. Here's the given rate. Here's what I'm trying to find, and here's the when. Okay, so I'm going to take the derivative with respect to t of this, right? The derivative with respect to t. I can tell that because it's got d over dt in here, right? So of x equals d over dt of y cubed minus y. So this left-hand side just gives me dx over dt. This side gives me 3y squared. And remember, multiply by the derivative of the inside, dy over dt. And the derivative of y will give me dy over dt. Okay, and that's what this line is, right? So then I plug the information in. So I plug in y equal 2. So I plug in y equal 2. And then I plug in dy over dt is 5. 5, 5. And, oops, I'm not there. Sorry. 5 right here. And then I can get the answer. dx over dt is 55. Whoa, okay, so now we're talking about volumes of things, so you can see the word problems are coming on the way. So let's make sure we're prepared, right? So there's my equation. That's my given rate, right? Because a derivative is a rate. Here's my when information and what I'm trying to find. So I take this, v equal 4 pi r squared, and I'm going to take the derivative with respect to t on both sides. All right, so let's make sure we're good. So derivative of v with respect to t is dv over dt. Over here, I carry the number 4 pi along, and then I'm going to take the derivative of the r squared, so that's 2r times dr over dt, because r is a function of time. So then, if I put these together, right, dv over dt, 8 pi, dr over dt, I think there's nothing to plug in, right? Oh, I'm sorry, I guess I did. I put the dv over dt as 100 in, and then can I find dr over dt? I can. It's right there. Okay, so let's do one more with the v's. So here's a v, given, a given rate, a when information, and a find. Okay, so if I take this v equal 4/3 pi r cubed. Okay, I'm going to take the derivative with respect to t on both sides. So this left-hand side gives me dv over dt. On the right-hand side, I just carry the number 4 pi over 3. Now I'm going to take the derivative of r cubed, which is 3r squared, times the derivative of the inside, which is dr over dt. So let me erase here so we can see what we've got. So they're telling me dr over dt is 5. Oh, look at that. And they're telling me that r is 3. Oh, look at that. So I can put 3 times 9, right? Carry along the 4 pi over 3, and then I can figure out the dv over dt, and that turns out to be that.